Since x is positive, y is positive, we know r is always positive because r is equal to square root of x square plus y square. Root of x square plus y square is always a positive number. Tan theta opposite by adjacent, that is nothing but qm divided by om, right? So that is nothing but q to m divided by o to m, opposite by adjacent. Sin theta and cosecant theta are positive and the remaining all ratios are negative. Cos theta is negative, tan theta is negative, cot theta is negative, and secant theta is also negative. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So today in this session I am going to discuss regarding very important concept of this second part of this chapter, allied angles. Now in this session I am going to discuss regarding allied angles to theta. Now before going to exact the definition of allied angles, let us know regarding the signs of trigonometrical ratios. Signs of trigonometrical ratios in the sense in first quadrant, second quadrant, third quadrant and fourth quadrant. You know 0 to 90 is the first quadrant, 90 to 180 is the second quadrant, 180 to 270 is the third quadrant, 270 to 360 is the fourth quadrant. So first, second, third quadrant, what are the signs of all these trigonometrical ratios? Now, the trigonometric functions of any angle already defined as sin theta is equal to opposite by hypotenuse, cos theta is equal to adjacent by hypotenuse, tan theta is equal to opposite by adjacent. So that can be written as sin theta is equal to y by r, cos theta is equal to x by r, tan theta is equal to x by y, and the other are the reciprocals of these, right? Now, let us consider this triangle. Here, this is x-axis, y-axis and angle theta. So, here OX, this is, let us call it as P and Q. So, here OQ is equal to X positive and OP, what is OP? OP is equal to R and PQ is equal to, what is PQ? PQ is equal to Y, that is also positive. So, here X is positive, Y is also positive. As usual, you know in the first quadrant R is also positive, or R is always positive. Now, here what is this equal to? That is, since R is always positive, the algebraic signs of these numbers depends on X and Y only. So, now let us consider the different positions of the terminal ray of an angle theta. Now, since x is positive, y is positive, we know r is always positive because r is equal to square root of x square plus y square. Root of x square plus y square is always a positive number. So, r is positive. Now, here the six trigonometrical functions, as we know, sin theta is equal to sin theta. What is sin theta? Sin theta is equal to opposite by hypotenuse, that is y divided by r, and cos theta is equal to adjacent side divided by hypotenuse, that is nothing but x by r, and tan theta is equal to opposite divided by adjacent, that is nothing but y divided by x, opposite divided by adjacent y by x. And similarly, so we can write the remaining. So the reciprocal of sin is cosecant theta. Cosecant theta is equal to r by y, and the reciprocal of cos is secant theta is equal to r by x, and the reciprocal of tan theta is cot theta is equal to x by y. So these are the six trigonometrical ratios. Now how it changes when this angle theta changes, right? So now that is, if the terminal ray of an angle theta lies in the first quadrant, we will get all these trigonometrical ratios as positive. See, sin, cos, tan, cot, secant, cosecant are all positive. That means in the first quadrant, all trigonometrical ratios are positive. Here all are positive, right? Because x is positive, y is positive. In first quadrant, all trigonometrical ratios are positive quantity. Now, move on to the second one. If the terminal ray of the angle theta lies in the second quadrant, so if theta lies in the second quadrant, then what happens here? This x is negative, and y is equal to positive, y is positive, and r as usual, this r is always positive. So y is positive, x is negative, and r as usual it is positive. Now the six trigonometrical ratios. Now how to write these six trigonometrical ratios? sine of theta in the first quadrant. What is sine theta here? Sine theta is equal to opposite by hypotenuse. What is opposite here? Opposite is y divided by r. Again, cos theta is equal to adjacent side. What is adjacent here? Minus x divided by r. And what is tangent of theta? Tan theta is equal to opposite divided by adjacent. Opposite is nothing but y divided by adjacent is equal to minus x. So, what you are going to get, this is a positive quantity, this is negative, and this is also negative quantity. And if we come to the second part of this, what is called, then what is cosecant theta? Cosecant theta is equal to r by y. This is again a positive quantity. And then secant of angle theta, secant theta is equal to r by minus x. This is a negative. And the final one, cot theta. Cot theta is equal to minus x divided by y. That is also equal to negative. Now, from this we can conclude that sin theta is positive and cosecant theta is positive. That means in the second quadrant, sin theta and cosecant theta are positive and the remaining all ratios are negative. Cos theta is negative, tan theta is negative, cot theta is negative, and secant theta is also negative. So, in the second quadrant, only sin theta and the reciprocal of sin theta is cosecant theta are positive. These two are positive, remaining are all negative. So, in the first quadrant, all are positive. In the second quadrant, sin theta and cosecant theta are positive. Now, move on to the third one. If the terminal ray, if this ray of an angle theta lies in the third quadrant. So, this is first quadrant, second quadrant, and in third quadrant. So, if the terminal ray R lies in the third quadrant, then OX is x-axis, x is negative, this is negative, and this y-axis, y is also negative, y is negative. So, negative x-axis, negative y-axis, as usual R is positive, right. So, x is negative, y is negative, R is positive. Now, the 6 trigonometrical ratios, let us take sin theta opposite by hypotenuse. What is opposite here? Opposite is equal to minus y divided by r. And cos theta is equal to adjacent side. What is adjacent side? Adjacent side is nothing but minus x divided by r. And then the tangent of angle theta. Tan theta is equal to opposite by adjacent. What is opposite? Opposite is minus y divided by adjacent is minus x. So, what do you say from this? So, this is negative by positive is a negative quantity, minus by positive is again a negative quantity, minus by minus it is a positive quantity. Now, if you reciprocate this, this implies what is cosecant theta? Cosecant theta is equal to r by minus y, that is equal to again a negative quantity. And what is secant theta? Secant theta is equal to r by minus x, that is again a negative quantity. Whereas cot theta is equal to minus x by minus y, negative by negative it is a positive quantity. Now, if you observe carefully, what is say? Tan theta and cot theta are positive, remaining are all negative in the third quadrant. So, here this tan theta is positive and cot theta is also positive. Tan theta positive, cot theta is positive because it is the ratios of two similar quantities, negative by negative, it is a positive one. So, therefore, in third quadrant, what do you say in third quadrant? In third quadrant, tan theta and cot theta are positive, that is tan theta, and the reciprocal of tan theta is cot theta are positive. So, what do you say? In first quadrant, all are positive. In second quadrant, sin theta is positive, and in third quadrant, tan is positive. So, in first quadrant, all trigonometrical ratios are positive. In second quadrant, sin and cosecant. In third quadrant, tan and cot. And in the fourth quadrant, what is left over? Sin theta, cosecant theta, tan theta, cot theta is gone. What is left over is cos theta and secant theta. So, if you observe carefully, so here in fourth quadrant, cos theta and secant theta are positive, remaining are all negative. Let us verify that. If the terminal ray of an angle theta lies in the fourth quadrant, if theta lies in the fourth quadrant, then what happens? So x is positive, y is negative, or as usual it is positive. X is positive, y is negative. So if you write carefully, what is sine theta? Sine theta is equal to opposite by hypotenuse. What is opposite? Opposite is minus y divided by hypotenuse is r. And similarly cos theta. Cos theta is equal to, what is cos theta? Cos theta is adjacent side divided by hypotenuse. Adjacent is x plus x divided by r. And what is tan theta? Tan theta is equal to opposite by adjacent. That is nothing but minus y divided by x. Okay. Now, so if you reciprocate this, cosecant theta is equal to r by minus y. That's equal to a negative quantity. Here this is negative, this is a positive quantity, again this is a negative quantity. Now move on to the reciprocal of cos theta is secant theta is equal to r by x. This is again a positive quantity. And the reciprocal of tan theta is cot theta is equal to x by minus y, that is a negative quantity. So what do you say from this? Now if you observe carefully here, cos theta and secant theta are positive, remaining are all negative. So that means in fourth quadrant, cos theta and secant theta are positive, remaining are all negative. So thus in first quadrant all are positive, second tan sine is positive, third quadrant tan is positive, and in fourth quadrant cos is positive. EASTC, that is all are positive, sine is positive, tan is positive, cos is, all silver teacups, all students take coffee. All are positive, sine is positive, tan is positive, cos is positive. This is how we are going to write the signs of trigonometrical ratios in first, second, third and quadrant, fourth quadrants. Now, move on to the exact signs of trigonometrical ratios. This is very important. Once if you know this table, then you can solve any problems in allied angles. So, x-axis, y-axis, x dash, y dash. So, here it is, this is 0 degree and this is 90 degree. 90 plus 90 is 180 degree. 180 plus 90 is equal to 270. 270 plus 90 is equal to 360. 360 plus 90 again comes in the first quadrant. So, this is first quadrant, second quadrant, third quadrant and in fourth quadrant. In first quadrant, all trigonometrical ratios are positive. In second quadrant, sine theta and cosecant theta are positive. And whereas in third quadrant, tan theta and cot theta is positive. Whereas in fourth quadrant, cos theta and secant theta are positive. So, ASTC, all are positive, sine is positive, tan is positive, cos is positive. Sine positive means the reciprocal cosecant is also positive. Tan is positive means cot is also positive. Cos is positive means secant is also positive. So, this is very important table for writing the allied angles. So, this is called the signs of trigonometrical ratios. That's it. Hope you followed. Very important concept. Now, by knowing this, let us come to the exact allied angles. Now, what are allied angles? So, if theta is an angle, which takes angles of the form n into pi by 2 plus or minus theta. Angles of the form n into pi by 2 plus or minus theta are called as allied angles. Angles of the form n into pi by 2 plus or minus theta are called allied angles, where n is any integer called allied angles to theta. Here n is equal to 0, 1, 2, 3, 4, any integer. Now, if n is equal to 0, then we are going to get plus or minus theta. Already we know theta, and this is minus theta. Angles allied to minus theta. Then if you put n is equal to 1, pi by 2 means 90, 90 plus or minus theta. If you put n is equal to 2, pi means 180 plus or minus theta. If you put n is equal to 3, 3 pi by 2 is 270 plus or minus theta. If you put n is equal to 4, 4 by 2 is 2, 2 pi means that is nothing but 360 plus or minus theta are all called allied angles to theta. So, here the angles minus theta, 90 minus theta, 90 plus theta, again 180 minus theta, 180 plus theta, again 270 minus theta, 270 plus theta, and 360 minus theta and 360 plus theta. 360 minus theta and 360 plus theta are all called allied angles to theta. Minus of theta, 90 minus theta, 90 plus theta, 180 minus theta, 180 plus theta, 270 minus theta, 270 plus theta, and 360 minus theta, and 360 plus theta. Now, we are going to connect the trigonometrical ratios for all these allied angles. That is very, very important. Now, to connect the trigonometrical ratios of minus theta with those of theta, trigonometrical ratios of 90 minus theta with those of theta, similarly trigonometrical ratios of 270 plus theta with those of theta, and 360 plus theta. Now, let us discuss one by one. Now, the trigonometrical functions of minus theta with those of theta, or 360 minus theta with those of theta. Now, let us consider Px comma y be any point on the terminal ray of the angle minus theta. Now, construct the angle in the first quadrant. Let us construct the angle in the first quadrant. Choose the point Q on the terminal ray of theta such that OP is equal to OQ. From figure, I will explain from the figure, triangle OPM is congruent to OQM. That is, OPM and OQM are congruent. That means OP and OQ are equal. That is equal to R, and MP is equal to minus MQ. This is the diagram. See here, let us P, O and Q. What we have explained, let P x comma y be any point on the terminal ray of the angle theta. This is P x comma y be any point, right? Then construct the angle in the first quadrant. Choose the point Q on the terminal ray as theta. Construct a point, choose this point Q as angle theta. Then such that OP and OQ are same, the distance from O to P. OP and OQ distance is also equal to OP. They are equal to R. See here, OP is equal to OQ, that's equal to R. They are equal. Now, next, then from the figure, we have these two triangles, that is triangle OQM and OPM. That is OPM and OQM. So, since these two triangles are congruent, we can say OP is equal to OQ, that's equal to R. OP is equal to OQ is equal to R, and M to P distance, this MP is also equal to MQ. These two distances are equal, but they are in opposite direction. So, they are in opposite direction. So, therefore, the signs are different. So, here the length is same, whereas the direction is different. So, therefore, we can write MP is equal to minus MQ. So, M to P, MP is also equal to MQ, but they are in opposite direction. MP is equal to minus MQ, right? This is the construction part. Now, let us come to the 6 trigonometrical ratios. So, this is very important. So, here triangle QS, OPM is equal to minus theta, OQM is equal to plus theta. OQM is plus theta and OPM is equal to minus theta, right? So, for this is an opposite side, adjacent side, hypotenuse. For this triangle, opposite is y minus y, adjacent is equal to x, and hypotenuse is equal to r. Now, let us write the 6 trigonometrical ratios. So, trigonometrical functions of this minus theta and 360 minus theta. Now, so let us discuss the trigonometrical ratios of minus theta with those of theta. Before going to that, let us write down the trigonometrical ratios of plus theta. What is sin theta from this? So, from this triangle, we have two triangles, that is OPM, another one is OPM. So, OPM and OQM from triangle OQM. Let us come to this triangle. What is sin theta? Sin theta opposite divided by hypotenuse. Opposite is nothing but, what is opposite here? That is nothing but QM divided by OQ. That is QM divided by OQ is also equal to OP. Now, similarly, what is cos theta from this? Cos theta is equal to cos theta adjacent side divided by hypotenuse. What is adjacent? Adjacent is nothing but OM divided by hypotenuse. Hypotenuse is nothing but OQ, right? Next, come to the tan theta. What is tan theta? Tan theta opposite side divided by adjacent. So, that is nothing but opposite is QM divided by adjacent side. Tan theta opposite by adjacent, that is nothing but qm divided by OM, right? So that is nothing but q to m divided by O to m, opposite by adjacent. Now the reciprocal of this will give the remaining. Now let us move on to the trigonometrical ratios of minus theta. Now let us take sine of minus theta. So what is sine of minus theta from this triangle? From triangle OPM, right? So that is from triangle OPM, from triangle OPM, from triangle OPM. If you write sine theta, what is sine theta? Opposite by hypotenuse. What is opposite? M into P divided by hypotenuse is nothing but OP. M into P divided by OP. What is this equal to? So, listen. Sine of minus theta, let me explain. Sine of minus theta is equal to MP divided by OP. Opposite divided by hypotenuse, MP divided by OP. Since we know what is M to P is also equal to minus MQ divided by OP. What is MQ divided by OP? MQ divided by OP is nothing but sine theta along with negative sign. That means sine of minus theta is equal to minus sine theta. Listen to me here. Now from the above triangle, sine theta is equal to QM divided by OP. From the below triangle, from this triangle, for negative angle, if theta is replaced by minus theta, what is sine of minus theta? Opposite by hypotenuse, MP by OP. So MP is also equal to minus of MQ divided by OP. Minus as it is, what is MQ divided by OP? MQ by OP is nothing but sine theta. So sine of minus theta is equal to minus sine theta. Hope you followed. Move on to the next one, cos of minus theta. What is cos of minus theta? So from this triangle, cos theta is equal to adjacent side divided by hypotenuse. What is adjacent side here? Adjacent is nothing but OM divided by OM divided by OP, right? OM divided by OP. Now, what is OM divided by OP? OM is nothing but same. OP is also equal to, OM is same. OP, what is O to P? OP is equal to OP is also equal to OQ. What is this equal to? OM by OQ. So, OM by OQ is equal to cos theta from this. This is equal to cos theta. See the difference. The first one is negative, second one is positive. That means cos of minus theta is plus cos theta. Now move on to the third one, tan of minus theta. What is tan of minus theta? Opposite by adjacent. What is opposite here? Opposite is nothing but MP divided by adjacent. Opposite is MP divided by adjacent is nothing but O to M, OM. Adjacent is OM. See here, sin tan theta opposite by adjacent, that is MP divided by OM. Now this is equal to, what is MP? MP is equal to, as usual, minus M into Q divided by OM. OM is also equal to same as it is, OM as it is. Now what is this equal to? Minus OQ divided by OM is equal to minus of tan theta, right? Minus of tan theta. Similarly, for cot of minus theta, what we will get? OM divided by minus MQ, that's equal to minus cot theta, minus of cot theta, this is minus cot theta. Similarly, for secant of minus theta, what we will get? That is OQ divided by OM, that is nothing but secant, positive secant theta. And similarly, cosecant of minus theta is equal to OP divided by minus MQ, that's equal to minus cosecant theta. Now, what do you say that? So, from this, if theta is replaced by minus, cos of minus theta is plus cos theta, and the reciprocal of cos theta is 1 by cos is secant. Secant of minus theta is also secant, and in all cases it is negative. So, cos of minus theta is positive and secant of minus theta is also positive. In other cases it is negative. So, sin of minus theta is minus sin theta, cos of minus theta is plus cos theta, tan of minus theta is minus tan theta, cot of minus theta is minus cot theta, secant of minus theta is plus secant theta, cosecant of minus theta is minus cosecant theta. Hope you followed. Now, Next, 360 minus theta. Now, if you observe carefully, this is, as I told, this is 0 degrees, 90 degrees, again this is 180 degrees, and this is 270 degrees, and again this is 360 degrees. So, 360 plus means it comes in the first quadrant, 360 minus means again it comes in the fourth quadrant. This is also equal to 360 minus theta. So, if the minus theta is replaced by 360 minus theta, then you are going to get the trigonometrical ratios of 360 minus theta. So, that is sine of 360 minus theta is equal to minus sine theta. Again, cos of 360 minus theta is equal to plus cos theta. Tan of 360 minus theta is equal to minus tan theta. Right. As from the sign convention, we have studied in fourth quadrant. What we have in the fourth quadrant? In fourth quadrant, cos is positive, secant is also positive, and all are negative. So, in fourth quadrant, cos is positive. Similarly, you can write cot 90 minus cot 360, right here. Cot 360, yes, sin cos tan. Let us write cot 360 minus theta is equal to minus cot theta. Similarly, for secant 360 minus theta is equal to plus secant theta, and the last one, cosecant of 360 minus theta is equal to minus cosecant theta. So, cos is positive and secant is positive, and other cases, in all other ratios it is negative. Hope you followed. Now, let us come to the trigonometrical ratios of 90 minus theta. Now, let us consider a triangle. So, let Px comma y be any point on the terminal ray OP. So, this is Px comma y be any point on the line OP. Let OPM is equal to theta, that is OPM, this is OPM, let us call it as OPM is equal to theta, OPM is equal to theta. So, I will write here, this is the triangle, this is the triangle, this is point P x comma y, then this is O 90 minus theta, and this is theta, then this is 90 degrees. Let us call P, O, and call it as M or N, whatever you want. You can take N or M. Now, from this triangle OPM, so here if I consider this, the sin theta from this triangle POPM, sin theta is equal to, this is opposite and hypotenuse and adjacent side. What is sin theta from this triangle? Sin theta is equal to opposite by hypotenuse, that is nothing but OM divided by OP, and cos theta is equal to adjacent side, that is nothing but PM divided by OP. Tan theta opposite by adjacent, that is nothing but OM divided by PM or MP. Similarly, cosecant theta is equal to OP by OM. Here secant theta is equal to OP divided by PM. Then cot theta is equal to PM divided by OM. This is for this triangle. Now, suppose if this is 90 minus theta, if theta is replaced by 90 minus theta, now from this triangle PON, what is sin 90 minus theta? Sin of 90 minus theta. Sin 90 minus theta, that is opposite by hypotenuse, PM divided by, from this PM opposite, this is opposite, then PM divided by OP, PM by OP. What is PM by OP? PM by OP is equal to cos theta. See, sin 90 minus theta is cos theta. Similarly, second one, cos 90 minus theta. Cos 90 minus theta. See, for second triangle, this is opposite, right? This is hypotenuse as it is, and this is adjacent. I will write it in the blue pen. So, sin 90 minus theta, opposite by hypotenuse, that is nothing but PM divided by OP. So, PM by OP from this triangle is cos theta. Similarly, cos 90 minus theta, cos 90 minus theta. What is cos 90 minus theta? Adjacent side is OM divided by opposite OP, OM by OP. What is OM by OP? Sin theta. See, sin 90 minus theta is cos theta, cos 90 minus theta is sin theta. Let us come to the third one, tan 90 minus theta. Tan 90 minus theta. So, this is 90 minus theta, opposite by adjacent. What is opposite? PM divided by adjacent is OM. PM by OM. What is PM by OM? PM by OM is nothing but cot theta. Right? Cot theta. So, sin 90 minus theta is cos theta, cos 90 minus theta is sin theta, tan 90 minus theta is cot theta. Similarly, I will write the fourth one, cot 90 minus theta. Cot 90 minus theta. Cot theta is nothing but OM divided by PM. What is OM by PM? OM by PM is nothing but tan theta here. It is tan theta. Cot 90 minus theta is tan theta. Similarly, fifth one, secant 90 minus theta. Secant 90 minus theta, from this secant 90 minus theta is nothing but hypotenuse by opposite. That is, what is hypotenuse by opposite? OP by OM. OP divided by OM. OP by OM. What is OP by OM? OP by OM is nothing but cosecant theta. And the last one, cosecant 90 minus theta. Cosecant 90 minus theta is equal to secant theta you will get. So, that means sin 90 minus theta is cos theta, cos 90 minus theta is sin theta, tan 90 minus theta is cot theta, cot 90 minus theta is tan theta, secant 90 minus theta is cosecant theta, and cosecant 90 minus theta is secant theta. This is how we are going to connect the trigonometrical ratios of 90 minus theta with those of theta. Hope you followed. Now, similarly, you can write the trigonometrical ratios of 180 minus theta. So, for 180 minus theta, straight away I will go to the ratios. Now, listen to me. So, trigonometrical ratios of sin 180 minus theta is sin theta, cos 180 minus theta is minus cos theta, tan 180 minus theta is minus tan theta, cot 180 minus theta is minus cot theta, and secant 180 minus theta is minus secant theta. Whereas for cosecant 180 minus theta is equal to cosecant 180 minus theta is equal to plus cosecant theta. So, these are the trigonometrical ratios. Now, to write the trigonometrical ratio, the very easiest method is, let us write down the quadrant. Signs of trigonometrical ratios in all these quadrants. In first quadrant, all are positive. In second quadrant, sin is positive. Third quadrant, tan is positive. In fourth quadrant, cos is positive. So, 0, 90 degrees, this is 180 degrees, 270 degrees or 360 degrees, right. Now, in first quadrant, you will get 90 minus theta comes in first quadrant, and similarly 360 plus theta comes in the first quadrant. In the second quadrant, 90 plus theta in the second quadrant and 180 minus theta. 90 plus theta, 90 to 180 or 180 to 90, that is 180 less than 180 up to 90 comes in the second quadrant. Whereas in third quadrant, 180 plus theta and 270 minus theta comes in the third quadrant. 180 plus and 270 minus. Whereas in the fourth quadrant, 270 plus theta and 360 minus theta, right. So, 270 plus and 360 minus comes in the fourth quadrant. Now, there is one important rule, that is, for 90 plus or minus theta, for 90 plus or minus theta and 270 plus or minus theta, there is a core rule, there is a change. So, there is a change means sin is converted to cos, as we have seen in the first concept. So, for remaining trigonometrical ratios like 180 plus or minus theta and 360 plus or minus theta, there is no change, there is no complementary rule. So, core rule. So, if you know this, 180 minus theta comes in, 180 minus theta comes in second quadrant. In second quadrant, sin theta and cosecant theta are positive, remaining are all negative, and there is no change. So, sin 180 minus theta is plus sin theta, cos 180 minus theta is minus cos theta, tan 180 minus is minus tan, cot 180 minus is minus cot, secant 180 minus theta is minus secant theta, whereas cosecant 180 minus theta is plus cosecant theta. So these two are positive. First and last are positive, remaining are negative. Now if you come to the next 180 plus theta, 180 plus theta comes in third quadrant. In third quadrant, tan and cot are positive, whereas there is no change. Same, the trigonometrical ratio will remain the same. Now move on to this trigonometrical functions of 180 plus theta. So 180 plus theta means, so it is in which quadrant? It is in third quadrant. In third quadrant, tan theta and cot theta are positive, remaining are negative, and there is no change. Sin 180 plus theta is minus sin theta, cos 180 plus theta is minus cot theta, tan 180 plus theta is plus tan theta, and cot 180 plus is also plus cot theta. Cosecant 180 plus theta is minus cosecant theta, secant 180 plus theta is minus secant theta. So that is tan theta and cot theta are positive, remaining are negative. Similarly, if you write, so this is 180, 180 plus. So what I have written here, 90 minus theta. If I go to 90 plus theta, similarly, trigonometrical ratios of 90 plus theta. So 90 plus theta comes in, 90 plus theta comes in first quadrant. In first quadrant, sine and cosecant are positive, remaining are negative. Further, there is a change. So sine 90 plus theta is equal to cos theta. Cos 90 plus theta, cos 90 plus theta is equal to minus sin theta. Tan 90 plus theta, tan 90 plus theta is equal to minus cot theta. Cot 90 plus theta, cot 90 plus theta is equal to minus tan theta. And secant 90 plus theta, secant 90 plus theta is equal to minus cosecant theta. And the last one is cosecant 90 plus theta, cosecant 90 plus theta is equal to plus secant theta. See, the first one as well as the last one, cos theta, sin theta and cos theta are positive. The result is positive. Sin 90 plus is plus cos theta, cosecant 90 plus theta is secant theta, and remaining are all negative. That's it. Okay. Now move on to the next one, trigonometrical ratios of 270 minus theta. Right. Now in 270 minus theta, now see here, 270 minus theta, this is first, second, third, and in fourth, A, S, T, C. So 270 minus theta, this is 180 and 270. 270 minus theta comes in third quadrant. In third quadrant, tan and cot are positive. Tan theta as well as cot theta are positive, remaining are negative, and there is a change. So there is a change. Core rule is applicable for this. So sin 270 minus theta is minus cos theta, cos 270 minus theta is minus sin theta. Tan 270 minus theta is plus cot theta, cot 270 is equal to plus tan theta. See, tan 270 minus theta is plus cot theta, cot 270 minus theta is plus tan theta. Cosecant 270 minus theta is minus secant theta, secant 270 minus theta is minus cosecant theta. Let me repeat. So 270 minus theta comes in a third quadrant. In third quadrant, tan theta and cot are positive, remaining are negative. Further, there is a change. Sin is converted to cos. Sin 270 minus theta is minus cos theta. Cos 270 minus theta is minus sin theta. Tan 270 minus theta is plus cot theta. Similarly, cot 270 minus theta is plus tan theta. Secant 270 minus theta is minus cosecant theta. Cosecant 270 minus theta is minus secant theta. Now, similarly, if you write it for 270 plus theta, now 270 plus theta comes in which quadrant? In third quadrant. So, in third quadrant, cos is positive and there is a change. So, 270 plus comes in fourth quadrant, cos theta and secant theta are positive, remaining are negative. So, trigonometrical ratios of 270 plus theta. 270 plus theta comes in fourth quadrant. In fourth quadrant, cos theta and secant theta are positive, remaining are negative. Further, there is a change. So, sin 270 plus theta is minus cos theta, cos 270 plus theta is plus sin theta, and tan 270 plus theta is minus cot theta, cot 270 plus theta is minus tan theta, secant 270 plus theta is plus cosecant theta, whereas cosecant 270 plus theta is minus secant theta. So, cos theta and secant theta are positive, remaining are negative. Further, there is a change. Sin is converted into cos. Now, move on to next concept is 360 minus theta. 360 minus theta we have already written. The last one is 360 plus theta. Now 360 plus theta comes into the first quadrant again. 360 plus theta is in first quadrant. In first quadrant, all are positive. For 360 plus theta, there is no change. So for 360 plus theta, there is no change. So this comes in the first quadrant. So sin 360 plus theta is sin theta, cos 360 plus theta is cos theta, tan 360 plus theta is tan theta. Again, cot 360 plus theta is cot theta, secant 360 plus theta is secant theta, and cosecant 360 plus theta is a cosecant theta. So this comes in first quadrant. In first quadrant, all are positive. Further, there is no change for this. That is, sin will remain the same, cos will remain the cos. So sin 360 plus theta is sin theta, cos 360 plus theta is cos theta, tan 360 plus theta is tan theta, and cos 360 plus theta is cot theta, secant 360 plus theta is secant theta, and cosecant 360 plus theta is cosecant. This is how we are going to write the trigonometrical ratios of 90 plus or minus theta, 180 plus or minus theta, 270 plus or minus theta, and 360 plus or minus theta, as well as minus theta. These are called as allied angles to theta. Now, so to remember this very easily, let us make a table in your notes. Write a table as you have written for the standard angles. Write the trigonometrical ratios like sine, cos, tan, cot, secant, and cosecant. Then you write 90 minus theta, 90 plus theta, 180 minus theta, 180 plus theta, 270 minus theta, and so on. So prepare a table like this, and just practice, you will get an easiest. So to write this table, you ought to write the trigonometrical ratios. The very easiest method is just remember the signs of trigonometrical ratios. That is, in first quadrant, second quadrant, third quadrant, fourth quadrant. In first quadrant, all are positive. In second quadrant, sin and cosecant is positive. In third quadrant, tan and cot is positive. In fourth quadrant, cos and secant are positive, and remaining are all negative in their respective quadrants. Further, for 90 plus or minus theta and 270 plus or minus theta, there is a change. For 180 plus or minus theta and 360 plus or minus theta, there is no change. Once if you know this much, you can easily write the ratios for all allied angles. That's it. Hope you followed. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.